Lesson 2.6, we're going to be solving absolute value inequalities. So you're writing compound inequalities with absolute value. You're going to solve them. You need to solve some word problems. They're not that bad. All right, so this is kind of some background information here to help you think about things. So like equations, you can have absolute values in inequalities. And they look something like you have right here. It just has an absolute value, but it has less than or greater than. Or of course, less than equal or greater than equal to. So when you have a less than inequality with absolute value, that means the distance from zero is less than that number. So I can see right here, here's zero, right? So you have two spaces this way and two spaces that way. So less than is going in between, which is an and, as you should recall. And then the other one, greater than 2, means the distance from 0 is more than 2. That's why you're here at 2, but you're going above, and then you're going below. So a greater than is or. So less than is and, greater than is or. It's not as bad as you're imagining it to be. That is the key thing. If you remember that, the rest is almost the same as solving the equations. So basically what you're doing here is like last time. First, you keep it the same. See how this is the same. And then you flip your symbol and change the sign. And let's see if it's an and or an or. Same thing here. See, you kept it the same. Flip the symbol, change the sign. Now, there are rules to help you kind of keep track of no solutions and all real numbers and what's going to happen here. And that's the next screen. This next one is very important to write all these down. So make sure you pause and get all of these written down. So if you have less than or less than or equal to a positive number, that's an and. And I remember using the word land because the less than sign looks like an L, kind of, sort of partially feel like less than is and. So the word land, because the word gand wouldn't make any sense. It doesn't, like, why do you have greater than an and? Gand doesn't make sense. Land makes sense. So less than is and. If you have greater or greater than equal to a positive number, that's or. And now comes the ones where it gets a little easier to work with. If your absolute value is greater than or greater than equal to 0, it's all real numbers. Because that saying that distance is more than 0. That's everything. Everything is more than 0 away from that. However, less than 0 is no solution because you're saying the distance is a negative. Remember, absolute value says distance cannot be a negative. So your inequality has less than 0, no solution. But if it's less than or equal to 0, you have one solution because you can be equal to 0. So you would just solve it as equal to 0. You'd have one answer. And then like 0, this kind of goes together hand in hand here. If you have less than or equal to a negative, that is no solution. So if you're not write this down yet, pause this, write these down, then we'll keep going. Well, you'll keep going. I'm already done with this. All right, so our first example here, super easy. So this is a less than or equal to. That means this is an and, as is this one. These are both ands. So to solve an and, it's super easy. You write it down normally like this, x plus 7 less than or equal to 2. Then go to your left side, add the same symbol, and change the sign. So you should have like a mirror image kind of thing. If you have less than 5, usually over here, you should have greater than negative 5. And you're going to solve this the same way you did with the equations. So I'm going to subtract 7 from everything. So negative 9 less than or equal to x less than or equal to -5. Then to graph that, number line, there's 0. -5 is here, -9 is here. These are both filled in circles, and it's shaded in between them, just like that. All right, now your next one, this says less than 0. But if you go to your rules from the previous slide, less than 0 can't have that. So this is no solution. That's why learning the rules is very important. You save yourself so much time and trouble. So the question is, how do you figure out whether to use and or? It's a symbol. Less than is and. Greater than is or. All right, try to solve these three. So pause the video, work them out, come back. All right, so your first one here, I have x is less than or equal to 3.5. And since that's a less than, it's an and, so I add the symbol here, change the sign there, and I have nothing to solve. I'm done. So I just draw a number line. 0 is here, 3.5 is there, negative 3.5 is here. Put my dot, do my shade. Nice. Next one, this is less than a negative. Can't have that. No solution. Okay, so less than, again, it's an and. So write it normally, 1/2 w minus 1 less than 11. And then over here, add no less than symbol and put -11. Now start solving. So I'm going to add 1 to each of these. That gives me -10 less than 1/2 w less than 12. Times by 2 and everything to cancel the 1/2 out. So -20 is less than w is less than 24. So number line, boom, 0, 24, 20, -20. Both open circles and shading in between. Okay, so we're going to solve these three now. Now these are all greater thans. So these would all be ors. And you could have an all real numbers solution also. So first one here, c minus 1 greater than or equal to 5, or c minus 1 less than or equal to -5. You change it just like that. Solve. So c greater than or equal to 6, or c less than or equal to -4. So to graph this, you have a number line, 0, -4 is over here, 6 is over here. They're both filled in, and it's greater than 6, so right, and less than 4, left. Now, part B here, this is greater than a negative number, which means this answer is all real numbers. So all reals. You can say all reals or all real numbers, whichever one you prefer. Doesn't matter. All right, third one, a little bit of work first. So we're going to subtract 1. That gives you 4, absolute value, 2x minus 3, greater than 16. We're going to divide by 4. So absolute value, 2x minus 3, greater than 4. So we're going to do 2x minus 3 is greater than 4, or 2x minus 3 is less than -4. So move this over. So I'm going to add 3 to both sides. I get 2x is greater than 7. So x is greater than 3.5. Add 3. 2x is less than 3. Sorry, -1. That's 3, not 7. I have horrible handwriting. So -1. So x is less than -1. So it's greater than 3.5, or x is less than -1. So number line, 3.5 is here, -1 is there, sort of. They're both open circles, and we're going opposite directions. All right, so same kind of problem here. Maybe a little bit easier, though. So you're staying at hotels. Each hotel offers a 50% discount for the third night. The coach wants to keep the total cost, so total cost for all 3 nights, at $225 with an absolute deviation of at most $25. So what you're going to do is absolute value, x minus 225, less than or equal to 25, which basically means you're going to add 25 and subtract 25. So he wants no more than 250, but no less than 200. So your total cost has to fall in between those two to qualify. So hotel A would be 80, 80, and 40 because that's the discount for the third night. So that's 200, which is your lowest he wants. So hotel A would qualify. B is 105, 105, and 52.5. So let's add those up. So 105 plus 105 plus 52.5. That is 262.5. That's outside your deviation here. So that one's out. So 75, 75, and cut it in half, 37.5. So 75 plus 75 plus 37.5. That's 187.5. That's also outside your range. So that one's out. Now the last one, 90, 90, and 45. So 180 plus 45 is 225. That's inside your range. So that one works also. So Hotel A and Hotel D.